Aleks, lesson 10.2 or assignment 10.2, number 10. This is a review problem. It says this, use a graphing calculator to solve this word problem, including involving a polynomial of degree 3. So a 7-foot thick slice is cut from the top of a cube, resulting in a rectangular box that has a volume of 131 feet cubed. Use the Aleks graphing calculator to find the side length of the original cube. Round your answer to 2 decimal places. So let's get a visual first of what's happening here. So we have a cube. So if I can do this properly, I'm going to use tool there. Clone this. And so I should have 2 that are perfectly lined up in length. And these are going to connect like so. This corner here, this corner here, this corner here. And I'm going to use dotted here to represent this backside. Oh, that's not what I want to do. I want to use a dotted. There we go. So honestly, if I were to do this correctly, I would have a dotted there and there. So that's kind of the idea of what's going on. I might be able to, if I were to write, I don't know if I can get color white. Is there color white? Yeah. So do we kind of, oh. I would kind of have just some dotted lines on here so you can get some depth perception. So that's seeing through the cube on the back side. Okay, so the question becomes, when we look at this, we cut off a 7-foot thick slice. It's cut off from the top of the cube. So we cut off 7 feet. So the idea is something comes through and cuts it off, and I don't know if I'm going to be able to do this very well or not, but I'm going to certainly try. I'm going to just do blue here. And so something comes in and cuts through there. Yeah, this isn't working for me. I was going to try to have it cut through here across the side. So we're going to cut this way, 7 feet around. 7 foot. So all the way across here, we cut off part of this box. Like that. So it's 7 feet that we cut. So all this part of the box is now gone. All that in there, this top portion of the box is what's gone. Okay, so we got to figure out how do I come up with how much was cut, or what are we even looking for? Find the side length of the original cube. Okay, so how do we find the side length of the original cube? Well, here's what we know right now. The length times the width times the height, when it was an actual cube, is just basically x times x times x. But we don't know what those are. But we do know that this is become, if this has, these two are cubed, that this length and this length are exactly the same. So I'm going to represent them with x. They're exactly the same. The height has been changed. It's no longer a length of x. It's now, this portion right here is going to be x minus 7 because I cut off 7. Which means the volume, which normally for a cube would be length times width times height, or if it's a cube, simply x cubed. What we now know is the volume of this is a cube. Of the rectangle is length times width times height. And in this case, it's 131. So let's do it over here. 131 is going to equal x times x minus 7. X minus 7. So I'm going to use Desmos to solve this. I'm going to insolve here for x. I'm going to come over here and have 131 equals x times x minus 7. And whenever we insolve with Desmos, I'm going to do y equals the left side of the equation and do y equals the right side of the equation. Now the intersection of these 3 graphs is my answer, and I know it's going to be up at 131. So I'm going to make my y values go up higher than 131 so I can see this. I'll just do 160. There's my solution there. My length, my x, is 8.722, which means my drawing is not very accurate to scale at all. That's my answer there. So solving this, I get x equals 8.722, which that's the original cube base. Each one of those would be 8.722. And it says round to 2 decimal places, so what we would be actually typing into the calculator here is 8.72, and this is in feet. And so that would be our solution here. Now let's prove this real quick. Let's try it. We should get 131 when I multiply 8.72 times 8.72. Now remember, this was 8.72 and I took away 7, so it'd be times 1.72. Notice that we get, because of the rounding difference, we don't get 131, but that's what it'd be. If you wanted more accurate, you could do that 8.722 like we originally got. And you'll see this is now getting really close to being 131 feet cubed. So we did do it correctly. It was just my drawing wasn't to scale. I should have had this slice way down lower, but I didn't know what the solution was at the time. But there you go. That's how you do this problem here.